Hello there, this is Jabir, and today we'll see how easy it is to implement facial recognition with Python. So face recognition is a well-known piece of technology, but what happens behind the face recognition is a little bit complicated and involves good understanding of deep learning and computer vision to actually realize how state-of-the-art face recognition model works. But we won't go into that details today. Instead, we will implement a simple face recognition system with really small amount of code. So let's get started. So first of all, we have to open our terminal or our shell and type the command pip install face recognition. So you have to install a library called face recognition to do face recognition. Cool. So I assume you have already installed Python and probably using some probably using something like conda or pip to manage your environments or packages. So once you have installed the face recognition library, you can just write import face recognition, and okay, the library is imported. Now we have to okay, first of all, to detect faces and recognize faces, we need some faces, or we need some images with faces. So we have some images in our working directory here. We have some celebrity images, and we have to detect the faces and also recognize which celebrity that face belongs to. And we'll do it with this simple but elegant library. So the first thing that we need to do is load the images. That means we have to take an image and import it inside face recognition so that it can read that image. To do that, we'll call a function named load image file. So we can just do face recognition dot load image file, and then we'll just pass the name of the image file or the path to that file. So that will load the image, and we'll have to save the image. So let's call this install, and then we have the image. So if we want to see the image, and just do an time show. Okay, so we have the image now. Then we can actually first let's try to locate the face. So we have an okay, so for that, let's do an image where there are multiple faces, which is like a very reasonable thought. In real-time scenarios, we'll have frames or images where there will be multiple faces. So first, we have multiple faces here, and we want to locate in which positions there is a face. Okay, so for this image we have 4 faces, so we should have 4 bounding boxes. Okay, so we want to get those bounding boxes. So to get the bounding boxes, we have to use a function called face locations. This the names are very obvious, so we have to run face recognition dot face locations, and then we have to pass the image. So we have like this image stone image, which is not an image stone image, so let's call it full faces. Okay, so we have changed to full faces, and then we have to like pass it as a parameter, and then we also have to tell what kind of model we're using. So we'll be using a convolutional neural network to look at the faces, so that's why we have to pass this, and then we have to get the locations, so let's call it blocks. And I'm not running the model in a GPU based environment, so it's taking some time, but if you have a GPU, you can probably speed this up. So okay, so we have got the locations, and yeah, we get like a 4 set of coordinates. So how are they like organized? So the thing is, we have like this is the, so first discuss what an how an image is represented. So we have like it's this is the image is like a standard in standard numpy format. So if I print it, so it's like a standard numpy array like format. So from here we can see this is the width of the image, this is the height of the image, and these are different coordinates. Okay, so this is like the y1 coordinate, and this is the x1 coordinate, this is y2, and this is x2. So you see what's happening here. So we have first the x1 y1 coordinates, and then we have x2 y2 coordinates. The y coordinate is before the x because this is how the image is represented in numpy format or in OpenCV format. So if we take it and so if we take this, we'll get this coordinate points, and we can actually extract it. So let's say we want to extract a face 1, and we can do this multiple faces, and then we have to do y1 to y2, then x1 to x2, and we want all the channels. So this is like the y coordinates, this is the x coordinates, and this is the number of channels, and we have 3 channels, the blue, green, and red channels. So then we can just show it this one. Okay, we have an error. Why? Okay, actually this is x2 and this is x1 because this is smaller than this one. This one has to be before, so as we're indexing, this cannot be smaller. So this is the way the coordinates are sampled, and then if we run this one, we should get a face. Okay, get a face. So that's how we can actually locate each of the faces by changing the index. Okay, now the most important part. So how we can actually um, actually recognize faces. This is just telling me, okay, here's a face, but how can I tell that this is a face of Emma Watson and this is face of Emma Stone? So for that, we need an embedding vector. So what is an embedding vector? So the idea is when so we have deep learning models or CNNs or whatever, some model here. This is a model, and you give some image with face to that model, and then that model will give you a vector or just bunch of numbers. Now these numbers actually represent the facial details or facial I don't know what I should call it, encodings or something, uh, so that with this vector we can actually represent a specific face. So let's say we have a face of Emma Stone and another face of Emma Stone and very ugly Emma Stone. So okay, so this we have two vectors from the deep learning model, and then if we compare those vectors, in simple terms, this is just an array. We can also call it an array. So then if we like check or compare those two arrays, we'll see that there's very minimum change or very subtle changes between those two. But if it's another face, and then the error rate or like the difference between these two vectors or two areas will be higher, and that's how we know that these two are from different faces. So with that we can just use this function called face encodings to actually get the encodings of a face. So let's say we have a Emma Stone picture, and we run face nation dot face encodings. So this is a function, and then we have to pass an image. Okay, so we have to pass an image, and here before that, let's just read it into an image. And this one. Okay, so now we have an embedding. So let's pass this image to this embedding or encodings function and see what it returns. So if we print it, you can see that it returns an array with I guess has a shape of 128. Yeah, so it has a vector or an array with 128 numbers, floating numbers, floating point numbers. So those are are actually representing the face, like facial features or something. So with that, we can actually so we'll just take the first element because there's just a single face. We can actually pass multiple faces here too. So as it's just a single face, so we'll just take the first element and let's do it for another image stone image. One, and then let's just check if these two face encodings have like the similarities, or they are from the same face. Okay, so let's run it, and then we have another function which is called compare faces. So let's run like results face recognition dot compare faces, and here the first one is a list, the second one is like a embedding that you want to compare with. So let's say this is our this is the one that we want to compare with. So we have this vector and another vector which is also taken from image stone image, and then if we run it, uh, okay, I guess, okay, I actually this should not be an array but just this single face embedding. So then we can compare these two, and we print the result, we should get true. Now let's do it for another face and see how this works. So let's say another face from another okay, so we have another face, and if I now do the results, so this is a Jennifer Lawrence image, and this is another one is Emma Stone. So if we compare these two, should give me false. Yes, that's true. That's false. So with these, we can write very simple face recognition and face verification routines. So to do that, first we need a face database. Okay, so for our case, it will be like the face encodings dataset. So database, whatever it is. So the thing is, we'll save the encodings for different people, different faces, and then once a new face comes up, we'll try to match that new face with our existing database and see if there's a hit or there's a match. So to do that, let's create our database. So for that, we'll just do it manually. So we'll just, let's say we have a like a database, and then we'll have a, oh, we can do a dictionary. So here we have a name, and then we'll have a like a vector or a face encodings. Okay, so we can just simply write this part. So it will be like we, it will be, I know it will be a little long, or but that's, I guess that's one way to avoid writing a new function. So instead of writing a new function, you can just write in a single line. So first I'll explain it in a moment. So here we first read the image with this function, and then we take the encoding of that face, that image that we have already loaded, and then we save that encoding to this key, which is the name of the subject. So let's do another. We have so we have two Emacs and oh, don't know if I have been taking. That does not matter. So we can do this one, and finally we have another face in our database is Jennifer Lawrence. So we're done. So with that, we'll have a database of faces, our face encodings. So if we run this, we should extract all our face encodings from these three subjects. Now, if we want to verify, let's first do recognition. So for recognition, let's say we have a random image that we load, that we a random embedding or encoding that we get from a random subject. Let's just randomly choose Watson 2, and then let's try to match this random encoding with our face database. So we can do for key face database, we want to match. So we want to say if random, first we have to do face recognition dot compare faces, and then we have to compare this the random encoding with the face database encoding. So we have to do face database A, which is this thing here. So first here, okay, the name of the subject, and then we can compare it with our random encoding. If it is true, we do the first, because actually it returns an array, so we're taking just the first index. So if it's true, then we have a match, and we can just break and like print face match with uh, we run it. Okay, just a second. So okay, we have to use an array here. If we run this, we'll see that okay, we have to take 0 and face match with Emma Watson, and we can do it with other cases. to, for example, remove 3. And so we can actually verify this, that okay, it matches with the right face. In real life, we would not actually look through this face encodings list. Instead, we'll do something like a clustering. But this is good enough for a very simple example to understand how things happen, or like to implement a very fast or very simple face recognition script. So that's it, I guess, for today. And in a later video, we'll actually see how things happen behind the scene, how actually the model learns the face encodings and so on. Thank you, everyone.